I want to introduce somebody who I've learned a ton from over the years, Nilanjan Raychaudhuri. He really is an exceptional, developer of software, but beyond that, he's somebody who, really has a passion and a keen understanding of sharing what he's learned with software. So, without further ado, Nilanjan.
All right, so this, okay. 1 second. It's early morning, I'm still waking up here. Hello. Hello, okay, awesome. So this idea about talking about whether programming is an art and science kind of all started with, I was reading this paper from Canute saying programming is a form of an art. And Todd gave me a call saying, actually sent me an email saying, hey, Nilanjan, you want to talk in this conference? And I said, yeah, sure, it's a local conference, why not? I love this conference, and I'm from the town, I don't have to travel. And yeah, what's going to be your topic? And this is the area, and that time I was very, very emotional and reading about the stuff, programming is craft, and all that stuff. I said, you know what, I'm going to talk about whether programming is art or science. I think that's an interesting topic. Lots of people wonder about that. Why not? So the idea behind was that I will get enough time to kind of look into this subject, explore this subject, and come up with something, but unfortunately, I didn't. Okay? I have no idea what is art. I'm not an artist. I don't play any music. When I was young, I used to do lots of painting, but when people look at it, they said crap, and I've stopped doing it. I haven't done computer science either. I actually picked up programming on my own, so I don't know much about that either. To make this next hour useful to you all, I'm going to just talk about Scala. This is something I'm very comfortable with. I'm doing Scala for a long time now, so I'm going to talk about what is this programming language all about. Promise me, trust me, it's going to be very exciting. So Scala is a general-purpose programming language for JVM. Okay, so you can mix with other JVM languages, and it's a high-level language. It gives you a succinct code. That means you have to write less code to get more stuff out of it, right? And everything in Scala is an expression. That means whatever you do there, it actually produces a value, expressions. Actually, there is one thing I can talk about art here. So if you look at the definition of art, what's the definition? It's saying it's a form of an expression, okay? It's a form of an expression. It needs human creativity. I have no idea what creativity means. Nobody explained me. Okay? It needs some sort of imagination and something that you create which is beautiful and creates an emotional power. That's sort of kind of a definition of an art. Okay? So is this an art? It's actually created by Lego programming language. If you notice it carefully, it's a recursive tree. It's a recursive algorithm here. Okay? So branches are tree, all this goes recursive all the way. Is this an art? It's a form of creative coding, they say. They use something called processing, okay? This is a part of a music video. They're using, all this are computer generated, okay? What about this? This is a craft conference. We know what is this, right? A game of life. Right? We put in patterns and we see all this fascinating design coming out of it. Okay, is this an art? Not sure yet, right? Well, let me explain you a little bit. I think it's important to understand what do I mean by art, because there are many forms of art here, right? Whenever somebody says art, the first thing that comes to our mind is fine arts, visual arts, right? But there are other forms of art, like animation art or assembly art. That's the picture out there. This is the kind of an art form where people take random stuff, leftover stuff, combine them together to create something out of it. Okay? So when I'm saying art, I am actually trying to talk about its basic form. If you look at the Latin meaning of art, it talks about skill. Now, that's something I can relate to, and we can all relate to. We think, we at least know that programming is some sort of a skill, right? Okay, there is a skill involved. Now, if I can distill down, which I like to do when somebody gives me this abstract idea. So what is the core of an art when somebody says it's an art form, it's an art, I'm doing an art? It turns out there are 3 basic things. It's a little dark here, but I hope you guys can read it. The first thing says it talks about creativity, okay? Without understanding the real meaning of creativity, all I can say right now, it allows you to create new things, come up with original ideas, okay? Next thing it needs is imagination, okay? So you imagine something, you come up with an idea. There is an imagination involved. And third thing, these are the core 3 values of any art, is an expression, okay? Somebody uses a visual art, some sort of medium where you're expressing yourself. Because art, one way to think about it, is a very extreme form of individualism. Now let's see whether we can map those 3 core properties to this sample code. Okay? And now this is sample code in Scala, but we don't have to actually understand the language to think about it here. Why? Because what it's doing, there is a construct called future here, which is creating an abstraction over how you do parallel processing. Okay? So it took somebody's creativity to come up with the simplest form of expressing that parallel computing to me. To me, when I look at it, it creates a beautifulness in me. I feel like, wow, that's a very nice way to represent that. Not only that, there is an involvement of imagination here as well. Not only trying to create parallel processes, there is a mechanism using which it's actually composing them together in that for expression right there, in the for loop. So that takes somebody's imagination, thinking, wondering about that problem, coming up with original ideas, say that how can I take this hard concepts and come up with something simple that will be useful for other programmers. I would take that as an imagination as well. Okay, it takes somebody's imagination to take that leap, to go to that next level. Okay? And obviously there is an expression. How we are expressing here, we are using language syntax, we are using editor, we are using whatever tools we have, right? We are expressing ourselves. So that way, I would consider this program here is a form of art, and any programming for that matter is a form of art. I like this quote from Harold Abelson. This is the guy who started this MIT course about structure and interpreted of computer programs. There's a great book out there. If you haven't read it, I highly recommend to explore that book. And this is the first thing he starts with. He's actually starting a computer science course, a lecture, first class. He mentioned, I'm going to read that aloud because I think it goes very well with what we're talking about here. I would like to welcome you all to this course of computer science. Actually, that's a terrible way to start. Okay? Computer science is a terrible name for this business. This is MIT, computer science class, okay? First of all, it's not a science. It might be an engineering or it might be an art. Okay? Actually, I would prefer computing science as a more appropriate name for this. This is one I like. There are lots of definitions out there which similar. I picked up a bunch of them which kind of relates to programming. Let's take this for an example. About Frank Lloyd Wright, he's a famous architect. He's talking about creating something beautiful, suitable for human use. This reminds me what Martin Fowler talks about, right? Any programmer can write code that computers can understand. Good programmer write codes which humans can understand, right? It kind of relates to that too, right? We want to create something which is suitable for humans. This is another thing which is very close to my heart because I love constraints, because it's talking about, it's okay, we can design something, but that this brings an interesting question about all the programs that we write. Should we consider them as an art? We sometimes write crappy code too, right? And I like this definition because it talks about, wait, it all depends on what methods you have used, what kind of practices, what was your action, and what was constraints that was given to you. I'm a big fan of constraints, big, huge fan. If somebody gives me a white blank canvas and say you can do whatever you like, I don't think I can come up with anything. But if somebody can say, okay, I will just give you a red color and you have to come up with something, that's interesting, okay? And constraints is something we are all very familiar with. First of all, we are all given a crappy tools. The state of tools and libraries out there, painful, horrible, right? We all work with a crappy tool. We all at some point have to work with languages which are very restrictive, not expressive enough. We work with all constraints, right? We work with this constraint fundamental, simple principles, and somehow we can combine them together and come up with this code, the application that solves a problem. At this point, I want everybody to pat their back saying, you guys are doing an excellent job. This stuff is hard. Okay, it's really, really hard. The next thing I think goes very well with the idea of this conference. That is, to labor in art for any reason other than love is prostitution. We are here, we love doing programming because we want to do programming. Yeah, money matters, all this stuff matters. We have to earn food, family, all that stuff matters. But at the end of the day, we are here because we love this stuff. And that's what makes all the things very interesting. Right? So practice, this brings in very interesting thing that we do because we know that just reading hundreds of programming books out there doesn't make you a great programmer. Do you agree? Anybody disagree with that? And all the great programmers you have worked with you are the great programmer. The difference is that you practice, you work on the problem, you code over and over again, over and over again. And this is exactly what artists do too. They practice. I think it's safe to say that programming is a form of an art. In fact, I will take this one step further. I would say if you think yourself as an artist, your quality of work is going to improve drastically. I want you guys to think yourself as an artist. When you work, even if it's a day-to-day work, you think yourself artist because you're going to then think about creating something beautiful out there. All right, back to Scala. So Scala is object functional language. Okay, that means Scala combines object-oriented programming with functional programming. I'm assuming all of you know what is object-oriented programming. Okay, so I will talk about what is functional programming. Okay, so functional programming is programming with functions. So nothing new there. So I think it's very interesting and very important to understand what do I mean by functions. So functions are something where, let's say f is a function here. Okay, I'm not going to scare with you math here. There's no math here. So what I'm saying here is that there is an input range somewhere. Let's say I have a function that takes from integer to string. So my input range is all possible integer values, and my output range is all possible string values. Okay, so function is something that takes me from input to output. This is our bread and butter of programming, right? It's an abstraction. Now, there is something I can talk about science here, too. Abstractions. So abstractions is what we talk about all the time. Everybody, oh, let's build an abstraction around this. Let's abstract this idea so that we can come up with something that's reusable, right? Well, what's our abstraction? To understand an abstraction, let's look into a little bit, because these are the questions we should be asking. What is program? I've been saying programming all a while. Well, what is it? So programming program as a fundamental level is something that takes input values and produces an output value, right? I mean, at the fundamental level. It could be taking an HTTP request, coming back with an HTML response. So it takes an input and output. If I talk about just values here, that I take something input and output, is going to make our job very, very hard. So we build abstractions around it. How do we build abstractions? We say, wait a minute, we are talking about values. How about I classify them as a type? Instead of talking about 10, 20, 15, all these integers, how about I say, oh, there is an integer out there that represents all the integers. This is one way of doing abstractions, right? Then we have another abstractions. We say, wait a minute, now we can make functions that works with these types. right? Now, the interesting bit here is that if you all have functions, and functions, you can treat them as an islands in your program. They are not interesting as an island. They become interesting when you compose them together, right? That's what program is. We classify them as a type, we create a functions. Now we take all these functions, compose them together, and come up with our program. It turns out all the stuff that we're doing, all the tools that we've been using, there is a category behind it, okay? So in the mathematics domain, they call it category theory. So all these functions and types that we've been using without even thinking about it, if we add those laws, actually those laws are implicitly there. They are in play, they are in action. Some of us just don't know about it. We get category theory. Guess what category theory in math is? It talks about how to work with these abstract structures. Somebody thought about it. Somebody created laws around how these abstract structures work. It's amazing that we have this 100 years of mathematician, scientists' thoughts in our belt right now, in our disposal. If we can just take a leap and start learning about what is this category theory about, it will be shame as a programmer if you don't tap into this knowledge pool. So what does that give me? Why should I care about this category and mathematical concepts behind this? Well, it tells us, well, you know you're creating things, but do you know there are rules behind how you can create things? Wouldn't that be nice if you can objectively understand? One of the things that I've struggled really hard when I started picking up object-oriented programming is nobody taught me how to. Okay? Because to me, the art is fine, art aspect is fine, but the problem is art is very difficult to teach new ones how to do it. Because if you say, this is a classic response I get when if I ask somebody what is object-oriented programming, they say, I know one when I see one. Okay, there is no objective definition of it. That actually makes it a little harder for a newcomer, or was harder for a newcomer like me, that how can I learn this stuff? So I think there is a value here to come up and figure out that, okay, somebody have thought about it. There are rules how to create new things. There are rules of composition. We've been composing functions together, but there are rules out there that tells you if you follow this, you have a compositionality. And compositionality is the core value, right? That's how we solve problems. We take small things and we build new things out of it. And proof for correctness, this is something I'm very passionate about, right? I mean, there are knowledge out there where they can say that looking at your program, I can prove that will work correctly. Isn't that an amazing thing to have? I mean, it would be awesome if I have started having compiler 5 year or 10 year down the line, which can run and tell me your program's going to work correctly. This is something I liked about Dijkstra's comment. I was reading this paper called Interplay Between Mathematics and Programming, highly recommended, by the way. Very good paper. And he said, programming is one of the most difficult branches of applied mathematics. Okay, applied mathematics is the branch of mathematics that are used in science, programming, and all that stuff, architecture. And that's also fine. Computer science is not more about computers than astronomy is about telescopes, right? So I would say programming is a form of science as well, because there is a science in play. Whether we realize it or not realize it, it's implicitly already there for us. If we be conscious about it, we can tap into more knowledge. Now, what's also interesting is art and science usually sometimes go hand in hand. Let's look at this simple example of something called golden ratio. Lots of artists use this. For an example, think about simple thing like rectangle. What will be the height and width of a rectangle so that it's aesthetically pleasant for the viewers? And they use, like all the Greek temples and their architecture, use something called golden ratio to come up with that appropriate size of width and height. This is a classic example of art and science in play together. I'm sorry, I completely got distracted again. So Scala has something called type inference. Okay, what that means is you don't have to specify types. It will just figure out for you. Okay? And it figures out based on the value that you assign. Okay, it's statically typed language, but it doesn't have the verbosity of Java. Okay? And everything in Scala is objects. That's also very nice. So it's a nice, simple model to keep in your mind. So for an example, when you do 1 plus 2, like 1 space plus space 2, that gets converted to something called 1 dot plus. I mean, if you have done Ruby and all that stuff, this is kind of taken. That's exactly what happened. But something for statically typed languages is kind of a brand new. So I'm invoking a plus method on 1 by passing 2. So it's a very simple model. There is no primitives here. And another interesting thing about Scala is it creates this separation between object and classes, which is kind of interesting because let's take an example of Java here. In Java, we have something called static methods. Now, static methods really doesn't feel the model of object-oriented programming because now we have methods that are not part of an object, is part of a class. It kind of breaks the model. So when Martin Odeski, the creator of the language, decided, say, wait a minute, I want to come up with something simple model here. So at the end of the day, everything should be an instance method. But the trick I'm going to use is that all the static methods are going to go into a different place called object, and all the things going to, all the instance methods going to go to the class. But end of the day, everything get converted to instance method. This is actually nice because it's a simple model to keep in mind, and all the painful and horrible code that we see sometimes in the wild, and like people not getting object-oriented programming or coming up with that, the quality of the code out there. I mean, something simple like that really makes me emotional. I mean, it feels like, wow, I mean, this is a simple model that I can keep in mind and come up with a good design. That actually reminds me something that we can talk about here about art, which is emotions. Now, we all been here, right? We all kind of been here, got frustrated. Look, what is this, right? So all coming here. So there is an emotional attachment with the code. I mean, I know people talk about don't get attached to your code, but it's hard. I mean, we all, so at points, some get, oh, this is my baby. I created this. This is good. So we are sometimes very emotional. And this is also very interesting. This emotional, and some programmer can create that emotion to you, the other programmer, right? I mean, it could be somebody else wrote the code, and you looked at the code, and you got frustrated. That's creating an emotion. Which also happens for arts as well, right? There are types of arts where people look at it and get very emotional. I mean, they might feel happy, they might feel sad, they might start crying. I mean, there are lots of things happens. So I digged into further a little bit, and I found this nice article from Tolstoy about what is art. I mean, he talks about like 20 different things. Highly recommended link out there if you're interested in this kind of area. There are a bunch of stuff I kind of liked here. The first thing I picked up is that this is one of the means of intercourse between artist and audience. So it's almost like through an art, you're creating a relationship between two folks here. Okay, and that's one of the idea of the artist also. They want to make you close to the art. They want to share their feelings with you. And there is another thing that's very interesting. The art transmits thoughts and experience. It's also something that we do with the programming, right? I mean, you look at the programming code and you feel like, wow, there is a share. This guy looking at the code, I mean, that's a very nice way to do it. It must be very experienced. So you share your experience through the code. And there's another interesting thing that experiencing emotion, when we look at something art, something beautiful, something that we like, we're passionate about, we get very emotional about it. And this actually happens. Let's look at this example for a second. This is one of my favorite songs from Pink Floyd. I get really emotional when I listen to this song. Hello, is there anybody in there? Tonight if you can hear me. Is there anyone home? Come on, yeah. What about this? Have anyone seen Taj Mahal? That's good. So, I mean, I don't, if you have, this is one of the wonders, put it in your bucket list or whatever, okay? if you go there, you stand in front of this beauty, it does create, even if this is an architecture, it's a huge emotional experience. There is a love story behind this, but if you go in there, it creates a huge emotional, like an emotional experience, so that's pretty awesome. There's another form of art, right? This is Ritu Berry's collection. He's a famous designer. She's a famous designer. Look at the work there. I hope it was dark a little bit. I wish I could buy this from my wife, but I don't think I can afford this, actually. But this is really, really pretty. So I think underlying value here, underlying thinking about all this thing that art, types of art that we like and all we experience, there is something that we all appreciate, that is beauty. At the end of the day, we care about beautiful things. We like beauty. Okay. Now, that means if I can translate, if I can draw a parallel here, that means at the end of the day, if we have a beautiful code actually makes us happy. I look at some beautiful code and say, wow, that's good. That's really good, impressive work, right? I mean, that feels, I mean, have you had that feeling looking at somebody's code and say, well, that's a nice way to implement this? So what is beautiful code? Let me show you my version of beautiful code. I'm gonna put two one-liners here. Okay, the first one line is again a Scala example. Really doesn't matter though. It's what actually doing. I have a list of values here, and list of values here that I'm trying to partition. I'm actually creating two groups there. When I look at that line, it's actually expressive enough. It's communicating the intent, okay, and with perfect number of characters. The variable name itself participates in that expression, giving me the value, giving me the readability property, okay? It's amazing. I look at this. This is a very popular example in Scala as well. Lots of people use this. That one line, I could do so much stuff out there. And it's completely readable. I can get it, okay? Even if I don't know Scala. The next one is an example of an Haskell. It's a very trivial example, but it's actually showing you how to do factorials. Now, if you go to your mathematics textbooks and try to read what is factorial, you'll probably find this definition exactly like this. Now, what makes this code so beautiful is that the mathematical representation, and I can put in the code, and this is actually working Haskell code. This works. And exactly maps one to one. I think that's amazing and beautiful. I can exactly get it, if I don't know the language, what this code is doing. Let's look at another beautiful code, at least I think is beautiful, is this. I know. This like do while loop is really, Nilanjan, are you serious here? So I usually don't do this. I usually don't write code like this. Okay, this is the part of an implementation I had to do is build an highly scalable ring buffer implementation for message queue. Okay, so when I say high throughput concurrent implementation, the standard building blocks that we have in programming language is not available to me anymore. I cannot use them. Okay, so I had to go into, so I'm talking about a little bit of constraints here, right? I have given a constraints. I never done code like this. I had to go into actually use direct memory manipulation in Java. I use Java unzip here. And if you look at this, I use compare and swap. I'm actually using caching here. So what makes this code beautiful? First of all, I was up whole week working because this was hard for me. I never done stuff like this, okay? What beautiful about this code is that, first of all, any thread can come in any order, and my code will still work, and it's really high throughput. Okay, so this coding experience gave me a different perspective. That is, I never understood when people enjoyed writing compilers or parsers or performance tuning. I don't know what's the enjoyment, but when I did this, it was one of the greatest fun I ever had, at least last year. Even though this was one of the hardest things I've done, but I had tremendous fun. I was up till 2 o'clock every day that week, but still I enjoyed. I had a blast working it. So this sense of beautifulness, sense of having happiness and joy in coding, what Todd was talking about, it varies. It's in weird ways that we programmers tend to like doing stuff. I mean, in this case, the constraint was an amazing factor for me because maybe it's a challenge. I mean, I don't know. I mean, maybe something you guys know better than me, but there's something about this exercise that actually made it fun. But all of this turns out to be that beauty is subjective. The bunch of code I'm showing you might not be beautiful to you. The problem with this is it's not only true in programming, it's true in various art forms, because there are types of art forms that people don't like. For an example, let's look at this. This is a death metal, and there are folks out there who like death metal, but I don't get it. I really don't. What about this? This is the Japanese tattoo form expression here, but I'm not big into tattoos. I really don't get it why somebody going to do paintings here, but I mean, some people like it, right? So how can I take this subjective beauty and talk about it objectively? Isn't that hard? I mean, this is one of the things also kind of confuses me when people come in and talk about best practice. You should do this. But everybody has their own style. I mean, if you all start thinking about an artist, I just created a huge problem for your manager, actually, because you just got to go in. I'm an artist. I want to explore. I want to create my own art. This is a form of individualism. It's your best practice. I don't care about it, right? So that's going to make things very difficult. And we all, if you want to take all these newcomers in programming and all explain them how to write beautiful code, we have to come up with an objective definition of beautiful. What is objective? So that we all kind of understand. So I kind of digged further into this as well. So first of all, let's start with beautiful. What is this beautiful? Beautiful comes up with something like, oh, it's a senses and minds aesthetically. So it's pleasing the senses and mind aesthetically. Okay, that's one way, all right? So what's the other definitions of beauty? I found a bunch of them I just put out there. Somebody's comparing beauty with pleasure, okay, exciting aesthetic pleasure. Truth is beauty, okay? This is actually my favorite. Beauty is in the eye of the beholder. That actually doesn't take us anywhere. Really doesn't. So the definition of beauty that I found that kind of relates to programming a better way, I mean, we can draw comparisons, is from this Greek philosopher, Thomas Aquinas, okay? So he was tasked with, can somebody tell me what is beauty objectively? Define it for us, okay? So he came up with three things. Again, three things, okay? First thing, he came up with something called proportion. That means, is my parts appropriately proportional to my body as a whole? That means, is my finger appropriately proportional to the size of my body? Don't look at my belly here, but I mean, as a size, is that appropriate? Oh, that's one aspect that he thinks that should be. Beautiful things should have a proper proportionality here. That's interesting. Next thing he talks about is integrity. Is the thing that you're talking about beautiful? Does that stuff work? That means I can build a hammer with a glass. It might be proportional and everything, but if I try to hit a nail or something, my hammer will break. So that will fail the integrity check. So it's not going to be integrity check, okay? So something that works, something that solves the problem for there. And the third thing he talks about is something called clarity, okay? That means is that if you're saying this is a beautiful thing, should be simple to understand. They should have a clarity. Now, I think these three things maps we can find a nice mapping with what we do in programming. So instead of picking somebody's code about and showing whether beautiful or not beautiful, I'm going to show you my code. It's a Java example I had to write last year. Hold on, I'm struggling here a little bit. Okay, can everyone see this? Okay, so this is an example of, I was building this example for an online training that we were building at Typesafe. I had to do this in Java, unfortunately, but this is an implementation of OAuth. Okay, I'm using Twitter OAuth to do that. Now let's take all these three properties that Thomas was talking about and see how that relates to how we can use those principles practically. Okay, so it's saying proportionality. So I am solving an OAuth problem. My code is like 100 lines of class. In Java, you need 100 lines to do Twitter OAuth, right? Properly proportional, don't you think? More or less right there in that range. What about the parts? Now, it does have a bunch of methods in here. Are all the methods kind of same size? More or less. Some are a little bigger, some are small, but all hovering over 5 or 6 lines of range, right? That's one of the way you can use a proportional property for your code bases. Okay? Integrity check. Does this stuff work? So obviously this works, it's out there, people are using it, so it actually works and actually allows you to access Twitter and authenticate yourself. So that way it is integrated, it's right there, it's meant to solve the problem. What about simplicity? Maybe not, right? I mean, let's look at this. Is that understandable? I don't know whether you guys can read this good, but okay. Is retrieve request token right there in the domain, isn't it? OAuth, if you know OAuth, there is a concept of request token. So I can understand that. Registered user profile and user profile, all this stuff, maybe there, maybe not. I mean, the reason I have to explain this probably fails the clarity check. But this is exactly what Thomas was talking about, that objectively to come up with beautiful. I mean, I don't know, do you agree? I agree, it's up to the judge here, the jury's out on that, but I mean, still, somebody's at least trying. I mean, I hope we continue to focus on this or come up with some objective way to define this. What interesting about this as well is, if you look at some of the design patterns, so one of the best book I read about, even though I said I have no idea what is, nobody taught me object-oriented designing, one of the best book I've learned most of my stuff is from Ken Beck's Smalltalk Best Practices. Excellent book. Even if you don't do Smalltalk, please go read this. It's an amazing book out there. And it's not about he's saying, I'm an expert in this, and this is, thou shalt do it this way. No. What he's done, well, I'm doing Smalltalk for 10 years, and there are some things I found while I was practicing, and I think this is a good idea to do it. Because I always be a little skeptic about when somebody comes with best practices, but this makes sense. And if you take those practices like smaller methods and readable, all this is very funny how the guy, Greek philosopher, objectively defining beauty, and Ken Beck here telling you best practices about designing kind of maps together. It's kind of amazing to see that in action. All right. So beautiful code create feelings in us. Now, this is one human can create a feeling on another human if I can come up with a beautiful code. All right, so Scala has two things called def and val. So you can have methods created in class and val for functions. I don't think that's interesting at all. Let's talk about something interesting called higher order functions. You can take function and pass a function to the parameter. You know what? If I live here and not talk about anything about art and beauty, I think I've not done it justice, because there is something fundamental behind this in that we need to discuss here, that how someone can go and create a beautiful code. I think we should talk about this a little bit before I talk about Scala. I think this is kind of an important. How can I make, what is that? So create. And whenever I looked into the literature about art and programming and all this designing stuff, and it's this one word comes up over and over again, that is creativity, and have no idea what that means. So how can I take a young programmer out there and teach him and explain him how to create beautiful code? How can we solve this? Even if we don't even know what creativity means. So creativity is an interesting characteristic, don't you think? I mean, we kind of use that word without even thinking a lot about this. So what is this creative? Creative is something that involves imagination and original ideas. So how can someone come up with original ideas? Well, what does that mean? How can I do it? Or teach me how to come up with original ideas. Can we do that? So it turns out nobody knows. Nobody really knows how to do it. But one thing I do know, or there is a research done by a scientist called, there's a research done actually, but I'm slipping the scientist name here, I should have it soon. It says that it's not a talent, okay? You don't need talent to be creative. And now that's kind of relieving to me. All right, I was a little worried there. I mean, like, whoa, it's just a magical power I don't have, and I'm going to screw it up. But you don't need a talent. That's good. In fact, you don't even need an IQ. So when research has been done on a bunch of creative people, it turned out the creativity is the way you operate. Okay? There is a research paper there called What Makes a Person Creative, and research is done by Dr. Donald McKinnon. If you Google that, you'll find his paper. Okay, he has done some research on this area. So it says the way you operate, the way you do things, that makes, it's a process. It's the way you work, it's that what makes us different. So, and in that paper, he talks about you need to be playful. That actually, that's what Todd says that makes it struck to me, because he said that the Jim Warwick was all about playful. And playful, when I mean playful, I mean this is, if you forget everything I said so far, I think this is something important to take away here, okay? That is being childish, okay? I'm talking about being in a mode where you are childish. It's there, because in creative process, there is no failure. Okay? That means you are open to ask what ifs. Okay? This is some question that we don't get time to ask anymore, based on all the minimum marketable feature, time to market, all this stuff. All these stuffs are valuable. All these things are important. But you need to have a time where you can be playful. You can say, hey, what if I do this? What if I do that? It turns out that's the fundamental way of being creative. So I looked further, and there was an amazing video by John Clesh about creativity. And he nails it down very well. I kind of like his explanation too, saying that, well, there are 5 things you can do. Okay, I'm going to briefly spend some time on this because I think that might give some value to all of us a little bit. He's talking about creating a space. That means he actually talks about 2 modes. We are in open mode and closed mode. Right now, I'm very much in closed mode because I'm focused on delivering this talk, right? And he talks about creating a space. That means something. I mean, you're going from your team space to some conference room, maybe, okay, with a bunch of your friends. A space that is where you are not worried about your day-to-day. Oh, the story I have to deliver. Oh, that test failing. Oh, I have this iteration meeting I have to go to. All this stuff you can completely forget. You're just in a space and saying, it's like doing meditation, right? Maybe you can do a meditation for 5 minutes before you start that. Then he talks about allocate some time. I mean, we are all kind of have meetings. I mean, how about in a weekly iteration you allocate some time for saying, I'm just going to be wondering in this time. Whole team going to be wondering about some problem. Okay, maybe an hour or 2. Allocate some time is very important. There is another aspect, spend time. So when you allocate time, you need to make sure that you spend enough time, maybe an hour and a half, maybe 2 hours, not more than that, because then it would be, because you cannot, essentially. The reason you should allocate more than 10 minutes or 15 minutes, because when you go into the space, your mind will start wandering, right? It will say, oh, I forgot that email. I have to do that stuff. Oh, I have to buy something for my daughter. All these things will come in. So at least it will take 10 or 15 minutes to come to that state where, oh, I can talk about this problem, okay? So allocate enough time to that. And you're just going to be hovering over the problem. The reason you're coming to the space is because you guys are all talking about a problem that you want to solve creatively, okay? And then have some confidence. What is this confidence means? This is probably the most important property to have, is there is no failure. And I'm going to be childish. And this is very interesting. With childs, they always, what will happen, Daddy, if I press this button, that button, this button, what will happen? I want you exactly to be like that. Saying, yeah, I know that's the way to do it, but why? Why have we been writing this stuff? Okay, why are we doing this? Why we always have to send this report, TPS report, every end of the week? Why? Okay, and finally, humor. I mean, this is something I enjoyed when, this is something that I really like about all the good teams I've been with, like DJ for an example here, we used to have tons of fun. And humor is a great way to get into this open mode where you are being creative. That's the best way to transition. Okay. So underlying thought here is think. Okay, this is this is something, it's very weird that we've been talking about this now, even though we should be doing this, is that we don't spend enough time thinking. And what that means is that when you are faced with a problem and the first solution that comes to your mind, don't immediately take it. Think about it more. Okay, don't take the first solution that comes to your mind. Think about it a little more. I mean, this is exactly, ties very well with last responsible moment. You don't have to come up with the solution today. Don't. Wait. Because it doesn't happen to you guys. So if you think about a problem at night and next day morning in the shower, I know how to do it. That's exactly what I'm talking about. This is very interesting. I can share one experience with you without knowing all this stuff, because I'm at the client place. That's actually my first day or second day. My task was, obviously I haven't started anything, and they gave me a huge code base to take a look at, and I was totally bored. And during lunch, a bunch of us were getting together. We are essentially being playful, and without realizing it, and talking about, hey, there is a nice Facebook implementation of something called BigPipe. They use BigPipe to reduce the latency, time to first byte. How long does it take to send the first byte to the browser? And they have done it very creative way. And we were talking about, nobody talking about how to solve it. We just think, wow, it would be nice if we could do something like this. And I remember going back to my desk after the lunch and not having any stuff. I was just trying to be playful. What if I take these ideas that is not created, first of all, not originated because to solve this problem, and kind of mix them. What if I mix them and see what happens? And it turns out that when I tried to do this without thinking about any pressure or failure, because I was just being playful, because there is no failure, and there was a creative solution, and people thought about, wait, I never thought about doing something like this. This is awesome. So thinking is very important. Don't reach the first solution that comes to your mind. It's almost like creating nice jokes and humors, right? If you notice them, the best ones are the ones that take two different points of reference and interestingly combines them together, right? You immediately get the joke, wow, that's funny. That's what I'm talking about here. It brings to an interesting paper I've started reading from Leslie Lamport, a researcher in Microsoft, the paper about computation and state machines. And he's talking about that I believe the best way to get better programs is to teach programmers how to think better. Okay? This is a problem. We don't realize this. The thinking is not the ability to manipulate language. It's not a language. It's not a programming language. Programming language just comes and goes. Okay? Trust me, if you're a junior programmer, you will learn 5 programming languages at least in your career. And it's the ability to manipulate concepts. And this is very interesting because when I was a Java programmer, all these concepts, all these functional programming concepts was not available to me. Why? Just because the language is not expressive enough. And I moved to Scala, and suddenly new world opened to me, new possibilities. I mean, I've been lucky enough to do that, but if our thought process is restricted by a language, how can we come up with something creative? How can we explore all this knowledge pool out there? Wouldn't it be nice if I can talk about concepts that somebody already discovered, already there out there, and explain them in language agnostic way? So it doesn't matter whether you're a Ruby programmer, Java, or Scala, doesn't matter. Let's talk about this concept because I think this is interesting. So we should be talking about all this stuff. What is computation? Right? I mean, computer science is a terrible name. It should be called computing science because it's all about computing. But a bunch of us don't even spend time, or at least I didn't. I never explored this idea. What is type theory? What's the correctness? Wouldn't it be nice to have compilers, automatic checkers out there who can prove and equationally reason about your code? There are huge possibility out there. Why we are not reading about cognitive science? Cognitive science tells us how human mind thinks. Wouldn't it help us to create better libraries, better APIs that we can easily make other humans understand? This is something I want to close with is This was a fascinating paper, fascinating. It's saying the science of art. And this is the artist talking about visual and fine arts here. It turns out artists, without even thinking about it, implicitly or explicitly follows principles. There is science behind art. They use a scientific thinking to produce an art that will appeal more to you. There is a logic of art. There's a logic behind it. There is a rationale, the evolution rationale. Why artists have used such a way? What was the reason? And what is the brain circuitry? Is it a bad for art? I don't think so. It's going to make art evolve more. Because now people will slowly understand the science. They will realize, okay, what are the things I need to do to come up with a good painting or good art? So I see beauty in both science and art. I mean, both are beautiful. So is programming an art or science? What is it? What is it? Since I've started with Knut, I think it's fair to end with him. Something that he wrote in his paper, which I really liked, is science without the art is likely to be ineffective, but art without science is certain to be inaccurate. Thanks. Any questions?
So, when you look at art,
Look at art.
any paintings, I don't know, I love Kandinsky, for example. He's very abstract, very close to me because, it's close to programming because programming is abstract. Had you had any experiences when you look at art, you actually got inspired as a programmer? It helps you to write some beautiful code.
Yeah. Thank you for the question. I mean, I'm a weird certain way. The thing that excites me most is cooking these days. And I'm a very big fan of this Iron Chef and the Food Network. And the way they approach and come up with create those dishes, I find lots of similarities. That's one of the reasons I'm thinking of taking cooking classes is they have constraints. They have this abstract ideas, which is use this crazy spice that has no one knows what is it, and anyway, and they come up with this beautiful dish which is pleasing, which is tasty. I find that very exciting and related to programming.
Inspiration is something that is really important in arts. So I've heard a lot within this environment of developing code, and there's also an well, I'm not inspired right now. I don't feel it. So how can you motivate that kind of inspiration? Or do you have to be patient in terms of managing a project where you really need your people to be inspired and be in the moment or the mood to create beautiful code?
That's wish I knew the answer. It's beautiful. I think it's hard because first of all, I mean, that code belongs to, right? I mean, if you are not passionate about programming, I don't get it. I mean, maybe the type of people I hang around with, they're all passionate. But I think that the idea of creating an environment where people can be playful, I think it's a great way to start. And because I think the horrible thing that you can do to a junior programmer is when he or she proposes a problem and everybody laughs at it. That's one of the horrible things that we could do. That's the best way to kill creativity. So I think the best way is to create a space where it is okay to fail. I mean, if you see some junior programmer has failed because he tried new thing, I think you should encourage that idea. I think that's one way to create that inspiration. Okay, everybody cares about this maybe. There's a question, yes.
I would like to know, sometimes we need to do some creative things and all, but how to do time management? Sometimes we feel, okay, we need to do, but due to some other things in our life. So how can we motivate ourselves sometime? So it's like,
What I said actually goes against the time management,
Yes.
almost, because whatever ideas I said, your manager's not going to like it at all. But it's interesting, spending time upfront thinking about types. Sometimes it's weird. I mean, I know we're just going to jump into evolutionary design and all that, but at times, I think it helps to spend some time, take a step back, look at the bigger picture, and maybe go to that space and think about, it wouldn't be nice if you don't even have to write a code to solve a problem, right, sometimes? So I think that's where the thinking helps, saying that, I'm not saying too much time. I'm saying maybe 1 hour for a group of people in your 1 hour in a week, okay? Maybe lunchtime, I mean, who knows? I mean, it's not even, and you can create this space where all those burning problems, and sometimes we do that all the time. Oh, this thing sucks, I wish I can fix it, but we never get time to fix it. But wouldn't that be interesting if you allocate the time and to just ponder about that problem? Have a space where people can be creative. Because you cannot be creative all the time, because the problem is, this is good, thanks for reminding, you can be creative all the time, because in open mind, what John Klisch was talking about is very interesting, is that you think about the problem, your mind wanders off, but that wandering is luxury when you have a deadline, okay? So you need to switch between these modes. You go to close mode. Close mode is where you have this tunnel vision, right? I have this story, I need to get this stuff done. You have to have that. But you need to switch between these two modes to be having something creative. Yes?
How do you deal with constraints and be able to sort of take those constraints and be able to inspire creativity from them?
Oh, wow. I just do it. Okay. Constraints, I mean, we all kind of used to it, though, right? I mean, like tools and languages that we use is not expressive enough. I think I'm turning this little interestingly, right? I mean, you can get a crappy work to do, a story that nobody is picking up, and which is like boring and something. Do this stuff over and over again. Sometimes I try to give an interesting spin to those problems, saying that, oh, how can I make this work interesting? How can I use these constraints as an encouragement, as a challenge to me? That sometimes helps. Like the whole direct memory access in Java, I never have done that. I never felt like. But when somebody gave me a challenge, oh, can you do it? Will be very interesting, will be very useful. The fact that somebody will find that useful and somebody will like to use that was enough encouragement for me to take a dive in.
Any other questions? Okay, thank you.
All right, thanks.